Okay. Okay, hello everyone. How are y'all? Sorry, I had a bit of technical difficulties, but we are here now, and so I am so excited to be here. Let me erase this so we all are on the same page. And I see a few people have joined TikTok, so hey, thanks so much for joining. If you have any questions, please feel free to put it in the chat, or you can send me an email. I'll be transparent and say it'd be better to send me an email, especially if you're on TikTok, because my phone is up there, but I'm here. So shoot me an email with your question, and you can do that to homework at SiSTEMtutoring.com. Sorry, I ran out of room. So just take a minute there, take a beat, and just go ahead and shoot me an email with any questions you might have. And then what I'll do is I'll just start like a quick lesson. I'd like to start with questions that people have, but if you don't have any, that's all right. I can just go over what I think you would need to know. So yeah, let me put my glasses on so I can actually see. And again, thank you so much for joining. This is gonna be so much fun. Let me actually change this. Sorry. There we go. So head over to that email, shoot over your information of what you're struggling with, and we'll get started. And if I freeze, that's okay, as long as you can hear me. I think as long as you can hear me, we are good. Okay. All right. I'm pulling up my information. And so today we will do something a little bit different. But before I do that, let me just check my email, see if anyone sent me something. Sorry, it's making me log in. Okay, it doesn't look like I have any emails. I'm checking yesterday if anyone sent me anything. And I don't see anybody sent me anything yet from yesterday. So That's totally fine. We'll just get started. And in today's topic, we will talk about solving quadratic equations by factoring. Oops. Oh, never mind. Sorry, I see a chat. It looks like they need help. Okay, it looks like, okay, polynomials. Okay, cool. Let's see. That's kind of on track with what I was planning on doing. So let's talk about polynomials. That's fun. Great choice. So I will pull up what the other thing I had, because that was on I had a similar topic I wanted to talk about. So we'll just start really basic. And all I want you to know is that polynomials are just numbers. You can think about it as simply as possible, is that it's numbers that have exponents on them. And you're probably wondering, what does that even mean? What are you talking about? How do I recognize them? And it's very simple. So if I was to give you a question like for example, let me just write something for you. If I said negative a to squared b, you should know that that could potentially be a polynomial. Why do you think it's a polynomial? It's this little exponent at the top here. Okay. Uh-oh, it looks like my screen is frozen. Give me 1 second. Let me refresh it. Sorry, it freezes sometimes. Okay, let me do that again. Sorry. Okay. I think my screen should be back. Okay, and I won't write in that corner because it looks like that corner gets blocked off by my my picture. And that's fine. So let me give you an example. So if I told you I have a problem like this, y to the 5 minus 3y to the 4 plus y to the 3 minus y, your brain should start firing off. Like, this looks a little bit crazy because it's a bunch of y's and a bunch of numbers. But the main thing I want you to pay attention to is these little exponents in the top. Okay? When you start seeing exponents, think to yourself, okay, I might be dealing with a polynomial. What's really important that students tend to forget is that when they see a number like this, a variable like this, y, where it stands alone, they think that there's a 0 on here. And I want you to know that that is incorrect. Whenever you see a y on its own, or an x on its own, or a z on its own, or even an a on its own, it's not 0. The actual exponent on it is a 1. Okay? And little individual mini 1. You can think of it as invisible, but I want you to always remember that it's a 1. I like to write it out just to make sure I remember that it has a 1 on it. It's not a 0. Okay? Any questions so far? I don't think I see any. I'm gonna quickly check. Give me a second. Okay, I'm not seeing it, so I'm gonna go back to what I was doing. No questions. Hold on. Oh, you sent an email. Okay, perfect. So I got an email from someone named Mia. Hey Mia, thanks for joining. Looks like we're gonna need polynomials and then domain and range. And did you want domain and range for polynomials or just domain and range in general? If it's domain and range for polynomials, I can do that. Super, super fun, super easy. Okay. So let's do some naming of polynomials. Yes, I can identify one and that's fine. But at the same time, you want to be able to tell what kind of polynomial you're dealing with, right? So let's erase that. All right, so when you have a single term like this, it is actually a type of polynomial. Does anyone know the name of this polynomial? What do you call this? And if you're not sure, I can tell you, these are called monomials. Why are they called monomials? Well, because mono means one. It only has one a or one term. And that one on the top. Remember what I said earlier? Whenever you have a variable standing on its own, there's an invisible one. So when you think of a term here, 10a, it's called a monomial. Let's try another example. If I tell you I have a 10k, oops, let me use the same color, 10k squared plus 7. What's this one called? Okay, no answer yet, but I'll just tell you this one is called a binomial. Why is it called a binomial? Because it has 2. That's all I want you to know for now. They're monomials and they're binomials and they look like those. So now let's move on to what an actual, so we talked about naming them monomials and binomials, but let's talk more about how we actually use polynomials, or when we'll see them and what they mean. So let's talk about adding and subtracting them. So I'm gonna write a question. So we have 5p, I'm gonna use the same color. Sorry, I keep using red, but I'll use black, so it's easy. 5p squared minus 3 plus 2p squared minus 3p. So this is actually telling us to simplify the expression. Here in these questions we're about to do, I'm going to do 2 of them. We're going to be focusing on adding and subtracting polynomials, okay? So all you need to do is find your like terms and start with the biggest number. When I say biggest number, I'm talking about this number here, the exponent. Look at your exponents and think to yourself, out of all of these, which one are the biggest? Obviously, this is the biggest, so we'll start with that one in the front. 3p cubed, write that one down. But be careful, 3p cubed has a minus on it, right? So you want to make sure you take the sign in front of the term with you. Do not leave it behind. So negative 3p cubed, we got that one. And then you go to your next terms. It looks like we have 2 terms that have an exponent of 2 on it. Not a problem. Circle them. I'll just circle them a different color so we know that we're dealing with different terms. So these 2, I'm circling the plus sign with it because I'm taking the sign with it. And these 2. So here, they're saying plus 2p squared plus 5p squared. We're going to do that in a moment. So we're done putting those together. And then our last term that's just standing alone or it's on its own is negative 3, right? So we put that on the edge here. So we have our polynomial, but we're not done. We want to combine like terms. You want to have one of each. We have one negative 3p cubed, so we can go ahead and keep that. But then we have our 2p and our 2p squared and our 5p squared. Just add those. What's 5 plus 2? 7, right? 7p squared. You keep your exponents. And then on the end here, you still have your negative 3. You didn't do much with it, and that's fine. So your final answer, when they say add this together or subtract this, this is your final answer. Negative 3p cubed plus 7p squared minus 3. And you want to do your answer in decreasing exponents. So my decreasing exponent, it goes from 3 to 2, and this one doesn't have 1 on it. Okay. Any questions? So that was adding polynomials, and I'll put that here. But what happens when they ask us to multiply? So when they ask us to multiply polynomials, it's a little bit different. Still the same kind of topic. You want to focus on adding and combining like terms. But I'll show you. Let me find an example. So here's one that you've probably seen before. Oops, I'm probably writing under my face, so let me cross that out. Okay, so 6n plus 3, 6n minus 4. So they're telling us to multiply these. What's the first thing we do? Super simple, it's called FOILing. And the FOIL method just says, take your first term and multiply it by the first term in the second parentheses, and then do the same thing over here. So when we do that, we'll get 6n times 6n, which should give us 36n squared. We have 6 times 6, which is 36, and n times n is n squared. And then we're going to do 6n times negative 4, and that is just negative 24n. We're going to do the same thing with the 3 here. We take the second term of the first section, and you're going to multiply that by the first term here and the second term here. When you do that, you'll get 3 times 6n, which is 18n. And then 3 times negative 4, don't forget to keep the sign in front, you'll get a negative 12. Oops. Okay. Now we're going to combine like terms. Look for the highest exponent. Don't forget, any n or variable that stands alone has an individual 1 here that we can't really see. This one does not have one. And so we're going to start here. It looks like we have 36n squared. We can write that one again. We got that. It looks like we have 2 like terms. These are the terms we have in common. Negative 24n plus 18n is, anyone want to guess? Negative 6n. Okay, that's all right. And then the last term here, there's no like terms, we just have a minus 12. This is our final answer. Questions so far? I don't see any. So we're going to move on to some more interesting polynomials, and then we'll work on graphing them. And then when we talk about graphing them, that's where domain and range will come in. Oh, actually, before we do that, let's actually do dividing, because there's a question about dividing, right? So this one before was adding polynomials, right? And then this one here was multiplying. And then this last one is going to be super fun. And this one's going to talk about dividing. Oops. All right, so let me find a problem for us. Okay, let's see, let's get a good one. Oh, this one seems fun. Okay, so we'll do m minus 8. I'll make sure I don't write on top of my face. So m minus 8, can you all see that? Let me just make sure. Yes, perfect. So m minus 8, and we're going to divide that by m squared minus 7m minus 11. Okay, so don't get stressed out. We're going to take it one piece at a time. And I'll show you 2 ways to solve this, but if we have time, but I'll show you the individual way, or the way that you should know just in case. So the first thing you're going to do is you're going to look at your first terms in both sections. When I say sections, I'm talking about there's a section here and there's a section here, right? those sections, it's going to be your quotient, it's going to be your divisor, or your dividend. Your quotient is the answer that you'll get in this top section here. Your divisor is this, m minus 8, and your dividend is this. Okay? So when I say sections, just think about it that way. I can use the words as well, but I don't want to confuse you. So take this term here and this term here and look at them and go, how many times does m go into m squared? And it's actually not a number. It's actually a letter. And the answer is m. All it's saying is, what is m squared divided by m? Or m times m equals m squared, right? So because I know m goes into m squared m times, I can put the m on top there. The next step, I'm gonna use a different color, is you take this m on the top and you multiply it down, similar to when you multiply and divide numbers, right? So now we're gonna multiply and we're gonna FOIL it to m minus 8. So m times m is gonna be m squared again, right? And then m times negative 8 is going to be what? Negative 8m, right? We don't have anything else going on. We're gonna do some math. M squared minus m squared, you must subtract here, just like when you divide regular numbers. Same concept. And then you'll get 0 for that. Or you can just ignore it because you don't get anything. Negative 7m minus negative 8m. This one sounds a little bit weird, but all it's saying is negative 7 plus 8. And that should just give you a regular m, or a positive 1m. Minus 11. You bring your number that you didn't use down. Okay? So now your brain should go, okay, I am no longer working with this section. I have completely done some math and I'm working on this section here. So I'm looking at this part and this part. Same process. How many times does m go into m here? M, right? Just one time. Because it's asking basically, what number do you need to multiply by m to get m? And it's only just the number 1, right? So just put plus 1 here. 1. And then you do that math all over again, right? Just like before, I'm going to erase these. But we're going to FOIL again, but instead we're going to use this positive 1. So positive 1 times m becomes, I'm going to erase that so we can see, becomes regular m. And then 1 times negative 8 should give you negative 8, like so. We're going to do some math again. We have some subtraction. M minus m is obviously, there's no more m, so we don't really care to write it. It's fine. But negative 11 minus negative 8 is basically like saying negative 11 plus 8. And so negative 11 plus 8 is going to be negative 3. So your answer here, believe it or not, is, if I can erase these, m plus 1. You're probably wondering, but what about this? You have a remainder. Remember when you're solving with regular numbers, not polynomials, and you have a number at the very end? That's called your remainder. So you can write it as remainder negative 3. Okay, so that's how you would divide polynomials. I think what we wanted to talk about now, since we have about 10, 15, no, we have 15 minutes together. We want to talk about, what's it called? Graphing polynomials. And so graphing polynomials is not as difficult. I think it's even easier. So I'll pull up a problem, but before I do, let me check the chat and see if there are any questions. Okay, I'm not seeing any questions as of yet. And that's fine. So I will continue. Let me check my inbox, sorry. I just checked the chat, but let me check my inbox. Okay, I don't have any questions. So the only question that I have is just to go over polynomials, graphing them, and then from there we can talk about domain and range. I'm just checking my spam too to make sure I didn't miss anything. Okay, I don't see anything in my email, so I'll just go ahead and start. All right, so the next step is going to be graphing polynomials. So I'll pull up my graph paper. And so like we talked about before, all we're doing when we're graphing polynomials is, and I'll pull up another sheet that's blank just so we can have something to refer to. So we have these two. All we're trying to talk about when we're graphing polynomials is a polynomial has this general format, right? Oops, sorry, my pen. So a polynomial has this general format, and it looks something like this, where you have your equation, and then you have a bunch of numbers, right? So you have like 2x cubed plus 4x squared, and it can honestly continue. It doesn't really matter how far you go. It doesn't matter how high you start too. I've seen polynomials that literally start from here, where they're like 4x 22. That's possible, right? So just remember, a polynomial has exponents on them. They're usually added and subtracted. They can also be multiplied, as we saw earlier. So let me erase all of this and we'll do an example. And I don't know, my pen is kind of messing up, so let me just check one more time. Okay, I think that's good. All right, so P of x is going to equal 2x cubed minus 3x squared minus 23x plus 12. So the first thing that you want to do when you are looking at your equation is don't get scared. There's just a few things we need to figure out before we even start. So the first thing is we need to find our leading coefficient. Our leading coefficient, and I'll write this down for you, leading coefficient it determines your graph's right behavior. So when you're drawing your graph, whatever happens to the right of it is determined by your leading coefficient. So it determines right side of graph. And you'll see what I mean in a moment. The other thing you need to know is the degree of the polynomial on that leading coefficient. That tells you the left behavior, what's going on in the left side of my graph. So the degree determines left side. up graph. So the way you can think about it, if we go back to the leading coefficient here, all we're saying is, in this entire equation, which one of these terms has the highest exponent, or the smallest, the biggest number? And the answer is 2x cubed. Why? Because the exponent on this is 3, this one is 2, this one is that invisible 1, and this one is none, right? So our leading coefficient is the number 2. The entire term itself is what we're going to be looking at. So the degree of the polynomial is 3. The leading coefficient is 2. The leading coefficient, like we said, talks about the right side of the graph. If it is positive, if it's a positive number, it means that our graph will be going up. And so I'll put that here as well. If positive, graph is up. What do we mean if it's negative, right? Obviously, if negative, graph goes down. So in this case, we have a leading coefficient of 2. Because it's a positive 2, we can say in this case that the graph will go up. I'll just circle this part because we know that our leading coefficient is 2. Now, the degree. We want to know what's going on the left side. We already know the right side will be going up. The left side, is it up or down? We don't really know. We can find it from the degree of the polynomial, which we said was 3. So here, we also pay attention. If the degree of the polynomial is even, an even number, then the graph will go in the same direction. So here, if even number, graph is up, up, or down, down. Okay, and then if it's odd, hope you can see because I hope I had room. What do you think happens if it's odd? It's the same direction, so we can. If the graph is odd, then it goes in opposite direction. So graph is either down, up, or up, down. Opposite direction. So in this case, is 3 an even or an odd number? It's an odd number, right? So because it's an odd number, we can say that the graph is going to go in an opposite direction on the left side, or the end behavior, sorry. So now all we need to do is, we've gotten that. We can go up to another page so we have it. We can say here, leading coefficient, just a recap, leading coefficient is 2, is positive 2. So graph will go up on right. And then here we got that our degree is 3, so opposite direction. And I'll show you what that means. But now what we need to do is we need to figure out what the y-intercept is. Meaning, where on the graph does my graph cross the y-intercept? And that's super easy. All you need to do is take your problem, 2x cubed minus 3x squared minus 23x plus 12. All you're gonna do is that everywhere you see an x, put a 0. 0, 0, 0. So when you do that, you'll see 2x, when you put a 0 in for that x, all of this becomes 0. That's 0, this becomes 0, this becomes 0. So it looks like your your y-intercept is just 12. So y-intercept is 0, 12. That's where your graph will cross. And then the last thing you have to do is find your x-intercepts. So that's you saying, where on my graph will I cross the x-axis? I've got where I'll cross the y, but where will it cross the x? Still pretty simple. You go ahead and write your problem. P of x equals 2x cubed minus 3x squared minus 23x plus 12. And we're trying to figure out what the x-intercept is. Please know you can have more than one x-intercept when it comes to polynomials. The way to figure out how many that you'll have is by looking at your degree. So if I go back, we found out that our degree is 3. So we should automatically say, I will have 3 potential x-intercepts. All right? And we have about 2 minutes, but I'll make sure to go fast here. What I'll do is I'll at least get the x-intercepts, and then you can go ahead and graph it. What I'll do is in the next session, which is normally pre-cal and geometry, that will start at 5:30. I will just start with this piece, so you can actually see me graph it, because we're running out of time here. And I want to give everyone a break, including myself. So after this section of finding the x-intercepts, come back in about 15 minutes at 5:30 for the pre-cal and geometry section, and I'll start with this piece so we can graph it. Cool? All right. So we'll know we'll have 3 potential x-intercepts. And so all we need to do to find this out is to figure out how many zeros, or what zeros that we'll actually get. So this is kind of where we can use some math. And now that I'm thinking about it, it's going to require a bit more time than a couple minutes. So let me just stop here because we're already at 5:15. Come back in 15 minutes. I'm sorry. Come back in 15 minutes. I'll start the subject of this in about 15 minutes on the pre-cal and geometry section. How does that sound? Okay. Cool.